is I hope you know that you've got a test on Wednesday. Is anybody surprised about that?
No.
You shouldn't be. And it took me years to figure this out, but if I give you all the handouts at the beginning of the semester, I wouldn't forget. And then now we have Canvas, so even if you lose the handouts I give you, they're available. So you've all had some practice questions to think about. And I'm going to start today by going over those practice questions. It's your job to stop me if you have any questions on what I do, or if it seems like a good point, clarify something you're doing. And not intentionally, but I tend to go a little fast during the review session, so also feel free to stop me if you have questions. And then finally, if you're too shy to stop me, this should be online fairly soon, in which case you can pause me on YouTube and I'll never even know that you paused me. We good? So, the first question that you're going to be asked about is the area between two curves. What I did was a few years ago, I went through and just looked at a bunch of old tests and found some questions on there. So the green graph is y equals cosine x. The blue graph is y equals sine x. And I think you've got s equals 0. And we've got x equals pi over 2. And there's actually two regions here. You get to go. I've got this left region, and I've got the right region. And so I'm thinking to myself, so there's always the question behind the question. The question is, what are the areas of those two pieces? What's the question behind the question? Do you understand the concepts that I taught you for finding the area between two curves? And remember, for area between two curves, we talked about how to do it with vertical strips and how to do it with horizontal strips. So I'm asking you to do one of each. Which one's going to be easier, by the way, vertical or horizontal? Yeah, vertical is going to be easier. So we'll do the left one with the vertical and the right one horizontal. And before I keep going, we need to know this intersection point. So what's the angle when sine and cosine have the same value? Is that pi over 4? Which conveniently is halfway between 0 and pi over 2. And what is the value of sine of pi over 4? It's also cosine pi over 4. So we got 1 over square root 2, or some people like to write that square root 2 over. So let's call this region A. And for region A, I'm going to do a vertical strip. I believe I exhausted all my colors already. That's black. So that is what a typical vertical strip in A looks like. Is that a dx or a dy? Is it dx? That's a little tiny slice of the x-axis. Or another way to see it is we're going to be using different x values to give us different slices. And then the area of a rectangle of base times the height. Is the height a horizontal or a vertical distance? So vertical distance. What letter measures vertical things? So what is the y to the bottom of this for region A here? So for this region, sine x is on the bottom, y equals cosine x described at the top, and that distance is cosine x minus sine x. The area of a rectangle is base times the height, and an integral adds up the areas of all those slices. What's the x value that starts region A? And the x value that ends region A? Yeah, region A stops here with an x value. In theory, you work through all these examples at home already, and this is a review, so I can go fairly quickly through it. You're going to stop me if it's too fast. Horizontal strips are going to be harder, and I'm going to just draw the right side here. Right side will look something like this.